Well, thank you very, very much for joining us. This has been a vision for a long time. We've been working on it since 2009. When we started, we were hosted by Cox Communications in Phoenix, I believe, and that's where it started. Actually, if I put the longer-term view, it actually goes back to Mark Coblitz and myself and others, probably close to 20 years ago. What was it in the 90s, talking about these kinds of issues surfacing, and we're seeing the reality. May take a little time, but we're there. A little bit about the attendance here. We're well over 150, close to 160, at a time when we were asked earlier by the senior folks to combine with Cable Labs if that made sense. Even with the commitment to Cable Labs, which is our great partner, it's a great turnout. I did want to make note before I get into it that our friends from Cable Labs and NCTA are here. In fact, we have Ralph Brown and team. Ralph, where are you? Okay, I'm sorry. Okay, good. And we have Bill Check and team from NCTA, which is right next to him. Very good. Good to see you. What's most important about this is how we're working together, and that the key is we're focused on network. We're going to talk about that in a little bit. And the Cable Labs folks and NCTA very committed to the CPE home and the residential side of our hardware. So to move forward, just let me make a few comments about where we are and where we're going. You want to take a look at, you probably have it on your table, the CED magazine. Okay. If you take a look at it, it's an example of where we are today. We've tried to capture some of the fundamentals around energy to be able to focus on those things that, as example, do you know? And it's kind of interesting because there's a broad spectrum of skills and understanding about the problem we're trying to solve. Some of it is very, very fundamental. Some of the fundamental engineering terms, what's a watt, what's a volt, what's a BTU, how do we work through these issues, what's some of the formulation and assumptions. Then there's really since we're the applied science of the partnership between NCTA and Cable Labs, how do we actually facilitate deploying these solutions and do it to scale in a financial and an economic way that makes business sense. This is all about business. We're here because there's a product and a service, and we're supporting a customer. It's around customer satisfaction and a viable, economically healthy, organization, which is our MSO partners. So this has many tentacles. So if you take a look at that, it's a pretty good example of where we've been working, what we're focusing on, but it's the informational piece. If you look at how we're managing by design, SCT is taking the role of saying, hey, there's a lot of solutions out there, but let's be practical about it. In order to ask an MSO or an operating company or partner to invest, we want to do it ourselves. We want to take the leadership role in saying, not only does the science works, but here's the best practices around the science, here's how the financials work, and we all know that a presentation with economics may be a little different than what you actually experience in an as-built network. So in this case, we're going to be the applied science model at SCT headquarters, and what you're seeing in this view graph is an installation of about 20 kilowatts in one full sun, and what's important about it is we're selling back 17 kilowatts to the PECO with Pennsylvania Electric. So we're actually generating revenue to help compensate for our overall energy consumption. Also, what comes from this is the mechanics of how do you do it? How does this actually work? What does the data tell us? Not just how do we engineer it, but after we engineer it, what happens? So we took the role and responsibility from a leadership perspective, saying, let's design it. We partnered with Alpha. Now we're looking at the real data and how do we apply it to the larger problem from a solutions perspective. You can go from kilowatts to megawatts to scale this. Also, if we look at how we're applying, we're going to eat our own dog food. And I know it's a term people go, eat our own dog food, what's that? Well, we're now part of the Comcast Business Services, and we're going to apply all of the learning we've taken on energy and how do we drive that into sustainability of our key services. And therefore, we're applying some of the new technology to include fuel cells and the application of hydrogen. And maybe a little story. My father was an engineer in the Apollo project working for Westinghouse in the early fuel cell days. And one day he came back and we're sitting at the dinner table. I said, Dad, you look a little different. He says, yeah, the fuel cell had a hydrogen leak and it kind of went off and we went in there with a match to see what was going on. And, in the early days, you didn't realize how volatile these fuels were. So we've learned how to manage them. And the eyebrow situation was basically the flashover from the hydrogen that was pretty common to the folks working on fuel cells. So we've gone a long way. So I look at what we did in the 60s to fuel cells, where the reliability was, I mean, they had to put 6 cells in a launch to hopefully have 3 or 4 operating when you return. In this case, the reliability is extremely high, very applicable to commercial applications. So we're going to say if our new opportunities are in business services, let's be the role model of how we harden these networks and deliver premium, high-performing services that can differentiate our industry, which actually can be part of a business model for our industry, where folks may not have those talents or skills within the business community, so that we can actually provide and develop the end-to-end solution, which will be optimal for us. In the use of, if you just go back to the fuel cell bit, the notion of how do we manage hydrogen, we're looking at all kinds of fuels. The whole notion of hydrogen being extremely dangerous, it can be managed like anything else. It burns vertically. In our meeting in Phoenix, in fact, the Cox folks were great. We looked at how different fuels may be volatile in the workplace that may be liabilities, right, for the folks in the field. So what was terribly important is that we're trying to understand that, and actually hydrogen-powered vehicles, hydrogen-powered technology in this case actually is very applicable and very safe. It's like anything. Apply the best practices, have skilled and trained and certified people managing it, and it'll operate as it would be expected and designed to do. So SCT is going to fulfill that role too. How do we apply it? We're going to provide certifications. We're going to provide informational material. We're going to do everything we need to make sure our workforce is optimized around these solutions. If you look at some of the low-hanging fruit, we're really driving around the lighting alternatives to include not just the power consumption change. As an example, we go from hundreds of watts in many cases down to 10, 20 watts for a solution, a significant reduction, but it's around color temperature. It's around how do we replace incandescent or fluorescence with these solutions. And it's really how does it fit into our environment. This is a key component of how we can find low-hanging fruit that has paybacks that are very, very attractive. Now, there's economic models we do with each one of these. Some are maybe a little longer, some of them are shorter. We're seeing, 18-month or so for the lighting technologies payback, so it can be very attractive. The bottom line is, from a leadership perspective, we said we'll make the investments, and I believe we understand and we're very critical about the financial side. We've reduced our energy by 43% just by taking the low-hanging fruit and applying what we believe is good science and technology and business to how we make these decisions. So what I'm leading up to here is the presentation you'll hear in the lead by Mark at Cisco and Mark Coblitz from Comcast is taking this to the next step, to be very serious around targeting and scale what we believe are the solutions to allow our industry to be sustainable and continue in the future and mitigate the problems through design in lieu of hitting these issues in kind of serendipitously in the future. So what's important is this message of what we're doing today, but what we're going to do tomorrow. So just to go back to make sure that we're real clear that the relationship with the NCTA, Cable Labs, and ourselves, I have to really give gold stars to Cable Labs and NCTA in partnering with us. This is a very a sensitive issue in some circles, that the collaboration to work these issues together is an equation of 2 + 2 is 5. I mean, the legal regulatory partnership we've got with NCTA, Cable Labs with the great intellectual base they've got to help us solve the problems, and we're all in this together. So just to make sure, we're going to focus on the network side. The folks at Cable Labs and NCTA on the CPE side, and we'll collaborate together where it's appropriate to make sure these solutions are optimized for our business. And that was important to us because we're going to focus on the network side, which is huge, right? Everything from the tap and the network piece, the fleet, all the way back to the video sources and other sources that we may partner or peer with in the community. Let me talk about some of the key programs we're going to be launching. Since we are the ANSI standards body for the industry, what's important is that kind of the synergies not only address the standards needs, but also how do we deploy those standards and scale with our vendor partners. So if you look at SMS 001 and 2, critical facilities and product environmentals, that is, I think 001 is pretty much established. 002, if you want to participate, I believe there's still some work, plus will there be continual upgrades and views. It's as simple as, in some cases, Do we vent hardware efficiently? Yes. What is that? Is it through the rear, through the sides? We're trying to be able to pull a percentage point here, a percentage point there. So our efficiency in these facilities are much better coordinated, and it's aligned to a set of best practices that we can all adhere to drive efficiency where it may not be obvious in many cases. SMS 003, which is called APTIS, that's Adaptive Power Systems Interface Specification. What's important about that is think of an environment where our network is driven by traffic, it's driven by commands from a host manager. But think of today, we have 3 and 4 megawatt data centers, right? That whether it's doing one transaction or fully loaded, how much energy is it drawing? Some of the work I had done in my previous research and development work was transactionally based energy consumption. If we're not transacting anything, providing value to the enterprise, why are we drawing energy against no transactions? So the assumption is APSIS is going to look at the whole network to include outside plant and what hardware would be most applicable, probably data center, larger facilities with hardware. To a model that we have, you could have a kind of a generic mode, it's in a standard mode, or be adapted to looking at traffic, looking at commands from a host, to include if we're in an enterprise situation where we have limited fuel. There is a catastrophic event. As an example, I live in Hatteras, North Carolina, which is the headquarters for hurricanes. So pretty familiar with disaster recovery because I've had to do it about every year since I've been there. Thinking about your fuel burn. If you've only got 3 days worth of fuel, maybe you need to reduce the traffic to primary services and extend your burn rate of your fuel to 3 or 5 days, from 3 to 5 days to 7 days, so that you can replenish and sustain, but continue to support critical services. So there's a lot of things that APSIS is going to adopt, but it's a critical development program that's being launched. And if you see Daniel Howard and the team, to include, we've got Marty Davidson now on board from Comcast Western Division, who is just an absolutely great asset. The team is really developing the program to be able to launch this and move forward. So if you're not a standards member, please join. SMS 004, which actually was an event that I had both the Comcast and Time Warner. Three critical issues. How do we improve the density of our products in a way that can be measured in a comparable way? Because today, the footprint of our facilities is basically maxed out in many cases. Where do you go? So the density of the hardware is critical. What's that methodology by which we benchmark it? Also, the energy consumption of that hardware, how do we measure that? Watts per QAM, watts per optical channel, what is that? So that's being addressed. The most important piece, and some work I had done earlier at actually Bell Labs, is how do we look at this from a network perspective? So making tough decisions doesn't mean you have to relegate reduced performance. We want to increase performance, and there's things you can do. We know that heat in the core is not helpful. It's actually reducing the reliability of the network. So we're going to be able to do a few things on how do we increase the network performance as we increase density and manage energy consumption. Another one is predictive alarming. That is critical to our business, where we actually have methods of looking at hardware in a preemptive way to alarm on imminent failure of hardware with a 90 percentile chance of actually catching that equipment. So we're going to be working on that. How do we optimize our network and customer satisfaction? And that's a critical component of the energy program, because predictive alarming, some of the data and signatures are going to come from silicon and some of the other components within the hardware that we can see a signature that will give us an indicator of that kind of a failure. And the last one, which is the virtual VD, 3D facility maintenance. What's critical about that is we're working in complex systems today that don't have all the telemetry we need, and also the fact that how do we virtually support more complex systems than we've seen in our lifetime. We're going to be able to look at from a graphic perspective and build a rack, right? Build all the hardware we need, have a virtual database, being able to troubleshoot it, but able to click on hardware, being able to see the specifications for the hardware and also see the telemetry. But that data will be accumulated in a three-dimensional way, so you can actually see temperature of hardware in a room in a three-dimensional basis. You can see airflow that's appropriate or airflow that's inadequate. You can see hotspots within the room. You can see all kinds of things that are preemptive strikes around performance, and also our tools to be able to help resolve some of the more complex systems, troubleshooting, and therefore mean time to repair. So these are critical that we're launching, and this is 6 out of, I guess we have 17, right? We have 17 projects that you'll be seeing emerging, and I'm sure that list will grow. So if you're not a member, please join Standards Group. Today we've got about 150 members, certainly led by Comcast and Time Warner and others. The Comcast Time Warner team is outstanding, really dedicating a lot of time and energy to this program. So you'll see a lot of support to make sure that the vendors and our MSO partners are realizing the problems we have to address, capturing them in the standards and best practices, and then launch. NBC Universal, which is here today, we're very, very grateful that we're a network. We're just not an entity. So we're looking at ourselves as a network that we would look across the interface boundaries to include, maybe there's a notion of, if we have an IP network interface, what about adding an energy layer of control to it that may be really creating, almost like you have a smart grid and a primary and secondary grid networks, doing that from a holistic network perspective, which is an energy management layer, right, of our IP network interfaces. We've got Nielsen Business Media, we've got Google, we certainly have a number of associations, so I think we're well armed to move forward in the standards arena. A little bit about us. How do we fit in the standards arena? We were in the top 15 ranking out of 220. I believe that's pretty good from a percentile basis from an ANSI accredited standards development program for the last 5 years. 262 approved standards, 25 adopted by the ITU, 3 adopted by the IEC. And again, we just won an Emmy, and I believe there's more opportunity to do it because in the period of the 3 years that I've addressed the development of new products and services, we're going to change the paradigm. We're not going to be passive. We will be aggressive, we're going to be professional, but we're going to be very focused on targeted objectives and execution. So if you want to be on the train, you better jump on it now because we're going to be moving and leaving the station here shortly. Folks that know me, you know, with a combat logistics background, getting the ammunition, water, and food to the folks on the front line is a priority, and you guys are on the front line. So with that said, I want to make sure we appreciate Mark Palazzo and what's going on. Cisco is committing significant resources. Mark is also supporting our Dartmouth program, which is a significant leadership program for the industry, very focused around the industry, specifically cable. But having sponsors and partners, not just sponsors, but committing the resources with expertise that is not necessarily common in the marketplace is very critical for us. And the relationship that's developed is important, like we have with many vendors. We want to be respectful of all the vendors in the community. But we appreciate what Mark and Cisco is doing and the support of Mark Coblitz in this presentation. So with that said, let me get really to the greatest value we have in hearing what Mark have to say. Mark, thank you very much.
Thank you, Mark, for the kind introduction, and to the SCTE for organizing this important and timely conference. You know, certainly if you drive a car, live in a house or apartment, fly on an airplane, you're no doubt aware of the challenges that we're facing today with respect to the rising cost of energy. While we've made great strides at increasing energy production, adopting conservation practices, seeking alternative sources of energy, we only need to look at the aftermath of the tsunami in Japan last year to understand some of the risks that are associated with some of those energy resources. It's becoming increasingly evident across the industry that the cost of energy and access to power facilities required to run our networks is going to have a profound impact on our industry. You know, thinking back, I remember how in 1979 I had the opportunity to build one of my first cable head ends. I was the official connector guy, and I cut more than my share of RF connectors, BNC connectors, and audio connectors. And I can remember this head end was 8 whole racks of equipment. And in those racks, we had modulators, processors, satellite receivers, a very simple passive combining network. I'm happy to say it was a full Scientific Atlanta head end, so the tradition started way back then. And this head end was housed in a single-wide mobile home, had 2 wall-mounted air conditioning units that kept the facility somewhat cool. And at the time, this was a state-of-the-art facility. My, how things have changed. Within just a few years, we were building facilities that housed up to 40 to 50 racks of equipment, more and more satellite receivers, modulators, processors, character generator equipment, eventually fiber optic equipment, transmitters, receivers, ad insertion gear, and the list goes on as we continue to add capability to the network. The facilities had progressed well beyond a single wide mobile home to raised computer room floors with forced air conditioning up through the floor, halon fire suppression systems, full standby power capability with full UPS capability, and really had become modern computer centers. Not too long ago, I had an opportunity to visit one of our customers in Beijing, China, and had an opportunity to visit one of their new head ends, a 200 rack plus facility that took up an entire floor of a high-rise office building in downtown Beijing. And again, if you look at how the industry's evolved, we continue to grow and add to our networks. As more and more services are added, new technologies are deployed, these facilities just continue to grow and consume more power. After labor costs and programming fees, the cost to power our network infrastructure and our head-end facilities is probably the single largest operating expense for most MSOs. And as the network expansion continues and the demand for bandwidth continues to grow, the cost of power to power both these data centers, advanced home gateways, and the network required to supply that power is only going to continue to increase. I think most people would agree that the demand for power is growing at an unsustainable pace, requiring bold steps to try to reverse that trend. We believe now is the time to take those bold steps. The time is ripe for enhanced collaboration between the vendor community with our customers, the operators, to find new and innovative solutions for this growing challenge. It's not enough for us anymore to just make products that are faster, smaller, and denser. They must be far more intelligent and more energy efficient. Power consumption and efficiency need to be more than just a spec on a data sheet. They need to be fundamental elements of the design of the product that start at the silicon level and continue all the way through the product and network architecture. And in my view, that's what SEMI is all about, and that's what we're here to discuss today. Vendors and operators that come together to work together to proactively address this growing problem of energy management, to find new strategies and new implementations to solve these problems. Industry leaders have got to come together to explore and define a vision and then go execute on that vision and the strategy to drive the results that we need for the industry. We're very fortunate today to have one of those industry leaders and visionaries with us today, and that's our keynote speaker, Mark Coblitz. Mark is the Senior Vice President of Strategic Planning at Comcast, and his primary responsibility at Comcast is to develop new business opportunities, particularly in the area of emerging technologies. Mark has played key roles in many industry initiatives. For many years, he was the member of the Cable Labs Technical Advisory Committee and the Technological Advisory Committee of the FCC. Mark helped to drive the development of the DOCSIS packet cable initiatives, as well as chaired Cable Labs Open Cable Business Committee. Mark founded Comcast's New Media Development Group, leading the exploration and development of new technologies and business relationships related to the cable business. In 2003, Mark received the NCTA Vanguard Award for Science and Technologies for his skill as a technologist, strategist, and leader. He was named CED's Man of the Year in 1999, and in 2004 was the recipient of the Broadband Innovator of the Year by Communications Technology magazine. Please help me to welcome Mark Coblitz.
Thank you. Thank you, Mark. I'm actually going to close this so I have a... Is that going to turn it off for you guys? All right, I won't close it all the way. You're welcome. Well, thank you, Mark, and many thanks to SCTE for this invitation to join you today, and welcome back to Philadelphia. I really appreciate this opportunity to talk with you about an important strategic issue facing our company and our industry. As many of you know, I've spent the last couple of decades of my career focused on strategy at Comcast. And strategy, of course, is all about positioning. It can mean positioning to enter new businesses or for growth in existing businesses, or it can mean positioning vis-a-vis others on our competitive playing field. Or it can mean positioning to protect your business and reducing business risk. The issue I'm going to talk to you today about touches on all of these considerations, and it concerns energy. I want to present the strategic rationale for how we can best ensure that the energy requirements of our broadband cable networks will be met in the face of rapidly growing demand. I'll propose that we define a process to address these issues for the long term, and I want to call on every stakeholder in this process, operators and vendors alike, to play an important role. Energy issues are a centerpiece of national and global public policy because they bear on a range of economic, strategic, and environmental concerns. Globally, the race is on to secure sustainable, renewable sources of energy, to improve energy conservation, and to make the energy grid smarter and more efficient. Like virtually every other industry, cable must confront the issue of energy management and formulate a strategy for the future. For a variety of reasons, we have already been focused on ways to increase efficiency, reduce power consumption, develop alternative powering sources in our facilities and our network in the home. Today, this focus and the need for long-term planning is more important than ever. The rapidly increasing demands placed on our broadband networks require us to anticipate how best to meet our customers' requirements for speed, capacity, and reliability. These demands our networks, in turn, create the need for more energy, as well as the increasing efficient use of energy. In today's world, our energy needs have proven largely manageable. But as we project consumer demand for our services in the future, as we see an impending risk several years down the road, the possibility that, without taking some important steps, we cannot always be assured of a sufficient and reliable supply of local available power. The demand for power associated with the rapid growth of broadband should come as no surprise to us. For the last several years, we have followed the quest of massive data center operators like Google, Amazon, Apple, and Facebook to meet their energy needs. As providers of broadband infrastructure, we are facing similar dynamics, but on a more localized basis. For the past decade, Comcast has seen a minimum annual growth of 40% a year in internet usage, with some years substantially higher. This has required our company to install more and more equipment, over 3,000 physical servers in our more than a dozen data centers last year alone. As the cable industry continuously increases the speed of our networks, that drives even more demand. In fact, while it's hard to hang a specific number on it, we see that each speed increase appears to be associated with another significant usage bump. We are constantly installing new CMTSs and blades, splitting nodes, taking other measures to stay ahead of demand. But we think the demand we've seen to date is the tip of the iceberg. Let's assume that our nation succeeds in a goal important to all of us, getting every American home, business, and institution connected to the internet. Given that about 2/3 of Americans are connected today, the expansion of demand for getting everyone connected can easily translate into another 50% increase in demand. And we can expect bandwidth demand from this larger user base to continue growing at least 40% a year. Let's also consider the growing sources of bandwidth demand. Up until this point, demand increases have largely been driven by growing complexity of web pages, an initial boom in peer-to-peer file sharing, and more recent growth in audio and video streaming services. Most of these uses, of course, mean that there's a human being interacting with a PC, a tablet, or some other device in roughly a 1-to-1 ratio. But the next wave of demand is likely to be driven by machine-to-machine usage, and in many cases by machine-to-no-one uses, such as security and home monitoring cameras that transmit data day and night with no human being actually watching. And since it costs them nothing, most developers of these types of systems don't look for ways to be network efficient. Experts in web traffic analysis have flagged these trends and included some of the less visible sources of demand. As Peter Sedzik and Rebecca Wetzel of NetForecast recently wrote, as iPads, iPhones, Nooks and Kindles, and other mobile devices multiply like rabbits and join the established population of desktop and laptop computers, the nature of traffic to and from all devices is changing. To the surprise of many app-centric activities, app-centric activities consumes more bandwidth than browser-centric activity, and much of the bandwidth is consumed by content that the user will never look at, as well as advertising that the user has not requested and has no say in receiving, as well as background and stealth traffic that the user probably doesn't even know exists. That and many other innovations will drive demand. Some of the most intriguing applications and a core aspect of Windows Phone and the soon-to-be-launched Windows 8 operating system is the capacity to automatically and continuously update the data in applications on smartphones and PCs and other devices that run 24/7. We are also seeing the rapid expansion of outdoor Wi-Fi as a complementary service for high-speed data customers. And this generates even more traffic to be processed through local wireline networks. And as 4G cellular services become mainstream in the next couple of years, consumer demand for immediate high-speed connectivity everywhere will grow. And wireless network providers will rightly be looking to offload traffic to wired networks as quickly as possible to conserve scarce spectrum. At the same time that we are seeing this booming demand for bandwidth by the internet, our video business is making its own IP transition in order to provide better services in a competitive marketplace and to take advantage of extraordinarily flexibility that IP offers. Cable is changing the way we deliver our core video products, moving from a highly efficient but gradually obsolescing broadcast approach to a unicast approach. Whether we are talking about video on demand or TV everywhere or just IP video, this means that more and more of the video watched by a consumer over our networks will consist of an individual bit stream dedicated just to that person or a tuner in one of their devices recording a program. And with multiple users in the home and outside the home, and with our typical multitasking user running multiple devices or applications simultaneously, bandwidth demand will grow and change in fundamental ways. With broadcast technology, the number of households and the number of simultaneous users within the household didn't really matter. But with the move to unicast, it matters a great deal. To the extent that a broadcast approach remains viable and efficient, it will likely be used. But the future clearly leans toward more and more unicast. And the demand from advertisers for increased targeting audience reach will require even more bandwidth, likely driving unicast delivery of ad content to be inserted into entertainment content, whether it is delivered in broadcast or multicast mode. And like most of the computer and internet industries, cable is moving more fundamentally into the cloud, out of the in-home device and into our networks. And a very effective way to reduce energy demand for our services is to move the extremely popular function of digital video recording into our network. The so-called network DVR removes the need for us to put energy-consuming hard drives, or what one day may replace them, solid-state storage devices, in set-top boxes or residential gateways. But the network DVR is more efficient, but while the network DVR is more efficient than millions of home devices, it also implies some transfer of energy consumption from the home power supply to our networks. And if I may digress for a moment, this also indicates how a legal anomaly can contribute to energy inefficiency. To meet the current requirements of copyright law and programming contracts, today's network DVRs are actually being configured as remote storage DVRs, or RSDVRs. This requires that a separate copy of every piece of content that an individual household might want to record be stored and maintained separately. If 100 people in a neighborhood all want to DVR the same show, there must literally be 100 separate recordings made and stored remotely. It is lost on no one that this is more expensive and uses more storage than would be required if the law and contracts allowed us to store one or a small number of copies for delivery and backup. But at least in my experience, no one has ever asked the question, how much energy does this duplication require? So let me give you some context. Let's assume the entire industry, not just cable, but everyone, supported 30 million set-tops or connected devices with a network-based service across multiple service providers and storage locations. I think it's a pretty reasonable assumption for DVR penetration. If the only choice we had was to implement RSDVR, we estimate it would require about 300 megawatts versus the 5 megawatts that would be used by a network DVR system supporting as many as 2 million different titles. When you start assessing not just equipment costs but energy consumption, it adds a whole new dimension to this issue. Consider that an average coal-fired power plant generates about 545 megawatts, and an average nuclear plant generates about 1,000 megawatts. So the difference in energy consumption between network DVR strategy versus remote storage DVR is fully 1/3 of an output of a nuclear power plant. And you can make similar calculations for energy requirements for any cloud-based service if a separate individual copy of each movie, TV show, song must be retained for each individual user. It really increases energy consumption. Let me highlight another service improvement that also has bandwidth and energy implications. We are making continuing effort to provide higher resolution video services. Today, most cable content is 720p 1080i, but almost every TV and computer monitor in the market today displays 1080p. An additional challenge with transmitting this format is that video frame rates can be as much as double depending on the content provider, in which action sports is especially demanding. And while significant advances continue to be made in compression and processing technology, this type of programming will require at least 20 to 30% more bandwidth. And this is only the beginning. As the 3D display market emerges, we are providing more 3D content, which today requires 33% more bandwidth to transport compared to non-3D channels. And at this year's Consumer Electronics Show, we saw new 4K devices that could come to market soon with demonstration planned for 8K. Whether as cable video providers we decide to carry this content or not, it is certain that others will use our broadband networks to deliver it however many devices are in the market. And whether that added resolution of 4K or 8K is delivered in broadcast, multicast, or unicast mode, this will dramatically increase the processing demand on our networks. And as we carry this type of content as part of our video offering, it will increase the coding, decoding, and transcoding processing demand as well. We are also changing the way we provide navigation of content to our subscribers, moving this function into the cloud. That is, into our network, creating more efficient and more functional search and retrieval tools. This includes whole home solutions with gateways that feed a class of set-tops that are less expensive and more energy efficient. It also means a major increase in the number of devices, not just TVs, but tablets, smartphones, game boxes, and other attachments that connect directly to our network. All of this growth requires more bandwidth, but not only to transport content to devices, but also to process billions of individual transactions over tens of millions of set-tops and connected devices. Every one of these devices will become a cable-supported device on top of many millions more internet devices, all demanding bandwidth from the network, which in turn demands energy. And just for good measure, let me add the rapidly growing base of business customers who are turning to cable services, and they require even higher levels of functionality, security, and reliability. Given the critical nature of many business and institutional communications, our ability to serve those customers depends on ensuring uninterruptible power and service. Service level agreements from these important users who represent some of the greatest growth potential for our business require us to plan and implement strategies for power continuity more demanding than anything we've known before. The energy demand issues I've been discussing are not limited to cable operators. Cable programmers and broadcasters are facing similar issues as they continue growth in the number of channels they deliver and manage, as live production becomes an increasingly important part of the business, and as the storage and movement of large video files continues to grow, companies like NBC Universal are also facing the need to secure reliable sources of power to their studio locations. Increasing amounts of available, reliable power could someday put limits on their growth opportunities as well. So to summarize everything I've just said, this is really, really good news. Our broadband networks are becoming more and more useful and more valuable to more and more people and businesses. And the HFC architecture the cable industry has deployed is standing the test of time and will continue to adapt to this extensive growth. Through careful planning and intense research, we continue to come up with cost-effective ways to provision the bandwidth the future will require. But in the face of this really good news, there is a risk. It is the one that we have identified now at a sufficiently early stage to address it effectively, collaboratively, and in an economically sound manner. We have been accustomed to a world in which we can always get the electrical energy we need, when we need it, where we need it, to deliver our services. We have had abundance, or at least adequacy. And in those limited situations where we have had power supply issues, we have worked around them by careful location of new data centers or just holding off on deployment until the electric utility can have sufficient generation and distribution to get what we need where we need it. However, given the current course and speed, we are concerned that someday, certainly not immediately, but foreseeably within the next 5 to 10 years, that we will be faced with the reality that our ability to grow will be constrained by the quantity and timing of obtaining electrical power. We cannot let that dependency occur. We need a new paradigm to think about energy requirements, one that is based on reducing business risk. And while there are many valid reasons to adopt this new paradigm, including broader sustainability goals, you don't have to be green to be dedicated to solving this problem. You just have to be committed to the continued growth of your business. There is a key way in which our issues are unlike those of Google or Amazon or Apple or Facebook. We operate local broadband networks. Those networks depend upon the distribution capabilities of the power companies that support us. While the operational facilities of a Google can be centralized at any location where ample power can be obtained and facilities can be moved or expanded opportunistically, cable requires the availability of sufficient energy to power each local head end, each hub, and even each node and amplifier at the neighborhood level. As we introduce more localized servers to handle increased loads, this will require more local energy to drive them. And these servers generate additional heat. This will require more local energy to cool our facilities, often within constraints of available real estate. If our networks are ready to meet our customer demands, but our suppliers of power are not ready to meet our energy needs, we will lose revenue, opportunities, and disappoint our customer expectations. We are determined not to let that happen. Everything I am describing requires us to look down the road a few years, and obviously that's a challenge for business people who have to worry about next quarter's results. But as an industry, we've done it before with great results. For example, in the middle of the last decade, we looked down the road and saw that a time would come when IPv4 address space would be exhausted, which could have severely limited our ability to introduce new IP-based devices into our networks. So our industry took the lead in migrating to IPv6. And last year, ICANN announced that the last available blocks of IPv4 address space had been delegated to regional internet registries. The supply was exhausted. We planned ahead and we were ready. When our industry first started discussing the IPv6 challenge, there were divergent points of view on tactics and timing. But with determination, hard work, and with a common end goal, industry thinkers ultimately coalesced around the idea of adoption of IPv6, that it was a strategic imperative. It would be critical to continue growth and new revenue generation. Comcast and others in the industry recognized the need to establish leadership positions in IPv6. We accelerated plans to integrate the protocol into our networks. We specified its inclusion in products we bought. We trained and prepared our engineering and operations teams to ensure a seamless implementation. The net result is that we are well positioned today to grow, not only by expanding our established broadband data business, but also by intensifying deployment of new IP-based services to tablets, smartphones, the television, and more. Imagine where we would be today if IPv6 had not been included in the first release of DOCSIS 3. That path was actually contemplated, as a way to reduce the complexity of that first release. But our industry took the long view, and it is really paying off. Now it is time to take the long view about energy. We are already seeing growing instances where available local energy is not reliably keeping up with the demands of our growing networks. To cite just one interest, and I will not mention the specific location, we had a recent situation where the combined effect of Comcast power demand increase, the local power company's capabilities, and a city's right-of-way requirements resulted in significant delays in the planned deployment of a data center and required us to place hundreds of physical and virtual servers in suboptimal locations. This resulted in our using more power than should have been necessary and expended a lot of human energy coming up with workaround solutions. These are the kinds of situations we don't want to have recur. Moreover, the rapid growth in broadband demand, coupled with the likely increase in cost per kilowatt, energy costs show no sign of abating soon, will add a significant cost factor, an expense we want to mitigate so we can focus capital on constant network expansion. I don't want to be misunderstood on one key point. This industry has made some enormous strides in energy savings. We have substantial improvements in processing power to watts expended and heat loads affecting levels of cooling, as well as more efficient cooling methods. In fact, Comcast's latest data center uses 70% ambient air for cooling. We are applying virtual machine technology to more efficiently use servers and software so we can shut down whole areas that are not needed at particular load levels. This lets us conserve power, and the more efficient use of our network and virtual machines lets us reduce the number of servers we need to install. Moreover, chip manufacturers have been focusing on better power performance capabilities for years, and those improvements show up in servers we buy today. Through these efforts, we are making progress in both peak load and ongoing consumption. And SCTE is making important contributions to these energy savings. Among the standards under consideration by the SCTE Sustainability Management Subcommittee is the one for Adaptive Power System Interface Specification, APSIS, which we're going to be discussing, that can vary power consumption based on network traffic demands, as well as another for predictive alarming that can provide notification and diagnosis of impending equipment problems based on signal variation within the network. And at SCTE headquarters, you saw that there's a demonstration of an innovative approach to powering in the absence of the grid when primary power is out. The organization has worked with leading vendors to create a hardened business services backup that leverages clean technologies, solar panels, fuel cells, and high-capacity storage batteries to maintain power for up to 7 days. And these efforts are terrifically helpful and important. And if they were enough, we could call it a day and go home. But we can't. Ask yourself, am I willing to bet my business that in the face of these huge growing demands for bandwidth and energy, the power will be there when I need it? At Comcast, we have asked that question throughout the company, on the cable side and the content side, and we are not willing to take that bet. Today, ensuring future energy sufficiency is a technical issue. The technical leaders in our companies and our vendor community can work to solve. I mentioned the IPv6 issue earlier and how we got ahead of that technical issue before it became a real business issue. Now, we can reasonably project an equally or more serious issue around energy. And once again, we have the power to solve it at the technical stage. Here's what I propose. The single most important thing we need to do is to change the way we think about energy, starting with the design phase. And by we, I mean the entire set of players that are part of our industry, including cable operators, vendors, cable labs, SCTE, NCTA, programmers, broadcasters, and others. And by others, I mean at the right time, we should reach out to other network operators who will face similar issues and who use similar types of equipment. It is no longer enough for our industry to specify a new design or set of functionalities without factoring in energy requirements, on the assumption that when the time comes to purchase and to deploy, we will be able to obtain enough energy to power what we have designed. Energy utilization must become an upfront consideration. To cop a popular meme, we need to think in terms of energy efficiency by design. By taking this approach, I am not implying that we will never decide to do something that takes more energy. Options are all about choosing. One option that is more energy intensive than an alternative may deliver more value in other ways to make it the better choice. But energy needs to be part of the choice. As we adopt this new paradigm, organizations like SCTE need to provide leadership in energy-saving methodologies and to help us to train our technical staff so that they understand the challenge and are able to operate with more energy awareness. It means Cable Labs must take energy leadership as a part of our specification design. It means we need lots of innovation from our vendors, breakthroughs in technology, architectures, and whole new ways of integrating those technologies and architectures into products and delivery systems. And in partnership with our vendors, it means that cable operators will need to purchase hardware and software that drives the economics of that innovation. And we will need to take a new look at how we process and distribute power in our installations as well. For example, how we handle AC and DC power. What the new paradigm does not mean is that we will need to have large new capital expenditures or discard lots of still functioning equipment. Our focus is on growth, and our need is to find ways to grow much more efficiently and let the natural equipment addition and replacement cycle take its course over the next decade. The new paradigm brings the added important benefit of getting ahead of energy consumption issues before it becomes something that regulators decide they need to address. Our industry has become a lightning rod in debates about managing in-home energy consumption. Government agencies, consumer organizations, and elements of the media have made unflattering assumptions regarding the power appetite of digital set-top boxes in particular. As I've noted, we've made great strides in the area of home energy consumption of our services, and we will continue to make more. We have already begun deploying in-home devices that perform fewer processing and storage functions in the home, relying more on the network and the cloud and reducing power consumption, while providing better consumer services. And Comcast just announced a service to help homeowners better control their overall electrical usage. The transfer of power consumption from the home to the network and the cloud that is associated with these changes may at first seem counterproductive to the improvement of operators' bottom lines, but it's important to note three things. First, network processing is more efficient than single device processing. Second, reductions in processing requirements for CPE will allow operators to recognize measurable savings in equipment costs and maintenance. And third, network and cloud processing allows for the more flexible delivery of new products and services that we need to compete. So in other words, we're going there anyway. The work I am proposing today should help address overall energy utilization and end-to-end architecture as we find better ways to support the increased network loads that the home energy improvements will drive. I believe that our new energy paradigm will allow us to take strategic rather than tactical and reactive responses to the broader network powering issues, and to do it on terms that work for all of us. So let me get back to the basic motivating premise for my proposal. I think the need for a new energy paradigm is not so much the near-term objective of reducing energy consumption or costs, but rather the long-term strategic need to ensure that we have sufficient power available when and where we need it. Where cost and environmental factors the overriding concerns, we might be able to address it in other ways, for example, through contracts with electrical suppliers or incremental changes in equipment. But the challenge is bigger than that. We simply do not have control over the availability of energy, the energy that we need to sustain our rapid future growth. What we can control, working together, is how much power we require and how we can require less than we otherwise would. I'm inviting you to take a very self-interested approach and view energy considerations in the context of securing future revenues. Our ability to configure our networks and our facilities to deliver new services doesn't mean much if the energy needed to power those services is unavailable or unreliable. While service assurance depends largely on a reliable primary energy source, there are a variety of additional factors that must be considered, most notably the ability to reduce load on equipment when service levels permit, the ability to anticipate and proactively avoid equipment failure, the need for backup powering that can maintain network uptime even when the primary source is down, and the need for disaster planning to accelerate network recovery in extreme circumstances. Again, we need to take a fresh look at our power architecture. Among the most important considerations is the need for plans that reflect the varied challenges across each operator's footprint. For example, it is likely that the power availability and potential service interruptions in the Northeast will be far different from those in San Francisco, which will be far different from those in Houston. And by the way, these needs are shared among cable operators, programmers, and broadcasters, which is one reason why Comcast is looking at this issue holistically and why our industry should do the same. Historically, equipment has been purchased and configured based on the business objectives at hand. Power requirements have been a tangential consideration, relating perhaps to the immediate issue of total loading of a single data center or head end. These considerations can no longer be tangential. They must be baked into our planning and procurement processes. As Steve Jobs might put it, we need to think different. We need to move energy considerations to the front ranks of our industry's concerns. We must give consideration to the efficacy, availability, and reliability of energy throughout the network and product planning process right from the design phase. The best way, the only way, to make this plan work is through open collaboration. Working together with industry organizations, operators, and vendors, we need energy considerations to be squarely on the table as long-range visions are discussed. We need to reach out to universities, government labs, and others where the best thinking is going on and take advantage of it. We need to get the power utilities on board. They have to be a part of the solution. This proposal will require serious attention and effort. It can't be done overnight, but it doesn't need to be. We had the foresight to take up IPv6 when in 2004, we at Comcast were predicting the exhaustion of IPv4 addresses in 2011 or 2012. Turned out we were awfully close. But we headed off a business issue then, and our goal is to head off a business issue now by thinking, planning, collaborating, and doing. Our energy consumption issue is what Brian likes to call a high-class problem. It's a direct consequence of the incredible growth we expect in our business, growth that will mean jobs, investment, and the central role our networks will play in our economy and our society. Broadband growth is an incredible social good. Please join us. Let's work together to make this growth, make it continue by ensuring that we have a real handle on our energy needs. We need everyone's help to meet the challenge. Thank you.